Good afternoon, everybody. Today, let me invite you for the session of discrete time Fourier transform topic, DTFT, discrete time Fourier transform, which is coming under VTU syllabus for 4th semester ECE students under module 4. This need not have to be for 4th semester ECE only. This can be to any discipline students or to anybody who is interested. Fourier transform is a topic which is required for everyone, right? For anybody who is doing MTech or PhD, right, in signal processing, they need this, right? Or in core engineering, they may be, many of you may be software engineers in core domain, and to do project, mini projects, whatever, you want this discrete time Fourier transform. Last sessions, we told you the importance of Fourier transform, right? Fourier transform tool. And let us see now today how exactly we can use the same tool to convert signals from time domain to frequency domain. What is that DTFT? What is that Fourier transform actually? DFT or Fourier transform? Fourier transform is a tool. Using this, we can convert signals from time domain to frequency domain. X of n to X of n. Signal from X of n to X of k. Frequency domain. X of n versus n to X of k versus k. That is also nothing but X of e power j omega versus omega. This is what DTFT. Right? Now let me do this. How to get signal X of n convert from time domain to frequency domain. We'll see through this problem. This one problem. Right? Simple problem. Find DTFT of the signal X of n, your input. Alpha X of n is equal to discrete time signals alpha to the power n into u of n, where mod alpha less than 1. What's the meaning? Here u of n is nothing but unit step functions. Alpha n, we have 100 times, we have done already. X of n is equal to, in your LTI representations, we have done this problem, right? N, X of n versus n, time domain representation. At alpha is equal to, let us say, there 0.9 something. When alpha is equal to, right, 0.9, for example, at 0, we used to get 1. Then afterwards, we used to get 0.9, 0.81, like this, we used to get. Right, this is what X of n input, discrete time sequence, X of n versus n with respect to u of n right sided sequence. What informations after all you get from this? Right, you don't get normally lots of information from time domain. You have to change this to frequency domain. That is X of e power j omega versus omega. That's what this X of e power j omega versus omega. Then you will get spectrum of these signals. Spectrum of this signal X of n, this signal. Where you can study, where you can analyze the energy of the signals, power of the signals, or bandwidth of the signals, or distortions involved in that signal, so that you can analyze any signals better. Right? Now, let me convert first X of n to time domain to frequency domain using a standard equations, and then later draw the frequency spectrum like this. Then from this spectrum you can see lots of things, right? You can analyze lots of things. Now, for example, to do this problem, what you have to do, right? Go to this, right? First write the formula X of e power j omega is equal to n is equal to summation, standard formula. Your summation n is equal to minus infinity to plus infinity X of n into e power minus j omega n. Right? This is a standard problem you are adding. Right? Now substitute what is X of n here, given things here. What you will get? This is this actually. Now you will get frequency domain representations X of e power j omega is equal to, what is what? Summation n is equal to 0 to infinity. Why? Because this is step functions. Now see this is given is step function. Step function means it exists from 0 to infinity. This side it is 0. Therefore, your summation starts from, instead of minus infinity, 0 to infinity, and your input is alpha to the power n into 1, u of n. See this? Alpha to the power n is alpha to the power n, u of n is 1. Right? Therefore, that is input. E power minus j omega n is there in the formula only. E power minus j omega n is there. E power minus j omega n, you write. E power minus j omega n. This is nothing but cos omega n minus j sin omega n. Right? Later we will see now. Now, immediately Simplify this. Summations n is equal to 0 to infinity alpha into e power minus j omega to the power n. Right? I am writing this equation only like this. Alpha to the power n. Like what is that? Alpha e power minus j omega to the power n. Right? In this form I am getting. Right? Alpha to the power n form. Then apply formula. Infinite sum formula exists. Right? 100 times we have used. Summations n is equal to 0 to infinite. Right? Infinity. Alpha into e power minus j omega into the power n is like this. Summation n is equal to infinity. Summation 0 to infinity alpha to the power n is equal to 1 by 1 minus alpha. This is the standard formula we have used. Apply this here. In place of alpha I am having alpha e power minus j omega. Therefore frequency spectrum x of e power j omega in frequency domain is equal to 1 by 1 minus alpha e power minus j omega. This is what? Frequency domain representations of your input x of n in frequency x of e power j omega versus omega. Now, let me plot this. I told you, right? Let me plot now for this x of n. Let me plot spectrum for this using these equations. Right? Let me plot the spectrum for these equations now. Now, I told you what is given in the problem is giving mod alpha less than 1. What's the meaning? Mod alpha less than 1 is nothing but alpha is right hand side is less than 1 greater than 0 this side, right? This side. Similarly, mod alpha is there, no? Maybe alpha is equal to 0.5, right? I am taking and I am drawing this spectrum. Second time I will draw for the left hand side I will draw. What is left hand side? Alpha value is less than 1, less than 0 and greater than minus 1 this side, right? This side minus 1 to 0 alpha I will write. This is minus, no? Minus 0.5 let me write. Right? Now let me do this here. First, what is that? Draw the spectrum now. After getting frequency domain representation, draw the spectrum for this. Right? For alpha less than 1, right hand side. What is the meaning? Alpha is less than 1, greater than 0. Right hand side. This side let me write. Now, how to draw? When you draw the spectrum, you will get spectrum of x of e power j omega. For less than 1, you will get spectrum like this. X of e power j omega versus omega. When you draw spectrum, you will get like this. Now this spectrum is useful compared to your time domain signal. Here there is a spectrum analyzer is there in MATLAB. If you go for MATLAB, there Simulink is there. Simulink software. There spectrum analyzer tool is there. To analyze this spectrum analyzer tool is there. Please go to the workshop, attend workshop, learn this, or else with curiosity you can learn in MATLAB software using MATLAB software, right? Or else I will take one session for that also, don't worry. Now, here using this spectrum analyzer, you can analyze this spectrum only. Spectrum where what is the energy of this signal, what is the power of the signals, what is the bandwidth of the signal, where exactly distortions occurs in the signals. Those are all informations you can, after drawing spectrum only, will know. Then you exactly in transmitting number of channels, right? Today's like you can exactly where exactly the distortions occurs only you can find out and you can correct, right? In frequency domain. That is why frequency domain representations is very useful compared to time domain. In time domain you cannot analyze all these things. For example, in this time domain, how can you analyze all these things? Nothing. You can't rectify whenever error gets. You only get mixing of channels, right? Now, when you draw this, what you will get? You will get like this. Now let me see. For example, right side, let me see. The alpha is equal to, let us say 0.5. Now, let me say for the right hand side. Alpha is equal to 0.5, let me take. Right. Then x of e power j omega is equal to 1 by alpha into e power minus j omega is the expressions which we got this is. Right. Now here you will substitute. We will see now. Omega is equal to 0, you substitute. Find out this value. Omega is equal to pi, you substitute. Find out this lower value. But omega is equal to 0, if you substitute, you will get maximum value. Spectrum like this. Omega is equal to pi, if you substitute, you will get minimum value. Now let me see how exactly I am getting. For example, alpha is equal to 0. X of e power j0 is equal to 1 by 1 minus. What is alpha? Alpha I am considering it as a positive side. 0.5 into e power minus 0. That is equal to x of e power j omega at omega is equal to 0 is equal to 1 by 1 minus. What is 0.5? 0.5 is nothing but 1 by 2 into e power minus 0 is nothing but 1. Therefore, this is 1 by 1 minus 1 by 2 is 1 by 2, which is nothing but 2. This 2 you will get at 0. Now see, x of spectrum x of e j omega at 0, its value is 2. Now see, this 2 you are getting that. Similarly, at pi you substitute here in this formula. For example, x of omega at pi, omega is equal to pi, x of e power j omega at omega is equal to pi. You will get 1 by 1 minus 0.5 into e power minus j pi. Pi you substitute. I know this e power j minus j pi formula is there. E power minus j pi is equal to cos pi minus j sin pi. That is cos theta minus j sin theta. What is cos pi? Cos pi is nothing but minus 1. J of sin pi, j 1 pi, 2 pi, any pi is 0. Therefore, it is minus 1. Substitute here this minus 1, 1 by 1 minus 1 by 2 minus 1. That is 1 by 1 plus 1 by 2. There is nothing but 3 by 2. Then there is nothing but 2 by 3, which is 0.67. At pi, you will get 0.67. Now see this spectrum. At pi, x of e power j omega at pi is 0.67 minimum. That's why you will get minimum. Here you will get maximum. Here you will get maximum. Here you will get maximum. Here you will get minimum, minimum, maximum, minimum. That is how you will get spectrum for a right-sided alpha value. Similarly, left-sided alpha value. This is the kind of flexibility you will get in when you draw spectrum in frequency domain. This is not there in time domain, right? Now you can easily analyze. Now go for a negative side alpha. What is that? Spectrum. Let me draw similarly spectrum x of e power j omega for negative side. Alpha less than 0 and greater than minus 1. Let me say minus 0.5 as an alpha value. Then you can, if you draw spectrum x of e power j omega versus omega, you will get same spectrum like this, exactly reverse of the previous. If you see at 0 you will get minimum value, at pi you will get maximum value. See this, for example, here at 0 you will get maximum value, at pi you will get minimum value. That is the spectrum for a positive value of alpha. Now this is the spectrum for negative value of alpha, minus 0.5. Now let me substitute how I am getting. For example, let alpha is equal to minus 0.5. X of e power j omega is equal to 1 by alpha into e power minus j omega. Now substitute here. At omega is equal to 0, this pi, I should get minimum. Let me see. X of omega e power j omega at omega is equal to 0 is 1 by 1 minus. What is alpha? Alpha is now minus 0.5 left hand side. Minus 0.5 e power minus j0. That is equal to 1 by minus into minus plus 1 by 2. What is e power minus j0? It is 1. That is 1 by 3 by 2. Then that is 2 by 3. Then this goes up 2 by 3, which is nothing but 0.67. Therefore, at omega is equal to 0, you will get 0.67. Now see, at 0, you will get 0.67. That is a minimum value. Then similarly at pi, at omega is equal to pi, see second one, you will get maximum value which is equal to 2. Now let's see. At omega is equal to pi, x of e power j omega is equal to omega is equal to pi, that is 1 by 1 minus 0.5 e power minus j pi. What is e power minus into minus plus? Now see, it is 1 minus into minus plus 1 by 1 plus 1 by 2 e power minus j pi, I know, cos pi minus j sin pi, which is nothing but minus 1, right? Substitute here, then 1 by 1 minus 1 by 2, which is equal to 1 by 1 minus 1 by 2 is 1 by 2, which is nothing but 2. That's what at pi it is 2. Now see, at pi it is 2. Maximum value is there. Exactly spectrum is exactly reverse of the previous negative, what is the positive alpha. Now this is how you will study. We can analyze, right, spectrum here. Now for this spectrum you can analyze frequency of this, what is the energy of this, power of this, maximum, what is the bandwidth, distortions occurs, everything using spectrum analyzer, right? Now that is useful information. Wherever channel the problem occurs, you can rectify and you can correct it and you can translate. That is where this is a very, very beautiful subject today we are all using, and that is how we are analyzing and we are doing, right, online transactions nowadays, online everything, online teaching we are doing now only without an error. Exactly like a board we are reaching now, you are all, because of these transformations, right? I hope I am clear. Let me repeat quickly, right, within 2 lines. First, it will give you one signal x of n. Then you have to get frequency domain representations for that using a standard equations, and then you will get frequency domain representations like this, right? X of e power j omega is equal to this equation. Then draw spectrum to analyze signals beautifully. Then if you go for right-sided, you will get this spectrum, right? Maximum at 0, minimum at pi. Similarly, if you go for negative side, right? If you go for negative side, you will get spectrum exactly reverse. At 0 it is minimum, at pi it is maximum, it is so, right? And like this, right? It seems I am clear in this class. I hope I am very clear, right? Next sessions we'll see, right, the more complicated signals. For example, maybe your rectangular signals exist between these, and afterwards it is 0. Then we'll see how exactly we'll get the spectrum for this, or how to analyze that in frequency domain. We'll see, right? Till that, thank you very much for your patience listening, right? Please take up these sessions to do R&D, right, or PhD or MTech, or your B projects, right, in Fourier transformations, or next discrete, right, DFTs, or then cosine, right, Hilbert transform, or wavelet transforms. All these are really useful. Today we are all, right, let's say thanks to this Fourier for these wonderful applications. Thank you.